you'll see me working back and forth between the two to explain this. Okay. The aquarium is, so we need to write the formula and then find the area. Okay. The aquarium is not a semicircle. I'm trying to find the aquarium. Okay. All right, I got it. So the aquarium is like the crust of the pizza, I guess, in some ways. I don't know if that's even, that's what I would call it. The aquarium and the study comprise a sector of a circle. Great. Use special right triangles where appropriate. Use right triangle trig where necessary. State answers in terms of pi until the very end of the calculation round. At the end of the calculation. Okay. All right. So hopefully they give you a straightforward one to start out here. So the pool is over here on the left, obviously, and its formula is pi times r squared. And what I'm going to recommend is that you come back and put in the right symbols for like pi, because it will take longer to do some of the formatting. But the area is, and then I guess you just put, when stating the formula, you must state the equation as A equals. Okay, so you have to write A equals. Hopefully you're seeing that, and then in the shared document, that you shared with me, and then we have to find the area. Okay, so the area is just putting the numbers in. I think that's in other cases you might. Okay. All right. So the area is pi times 18 squared, and 18 squared is 324, I think, although it's still early. I might get that right. Yeah, 324 times pi. And then question is, what are the dimensions? Like feet. So I guess we should say, and I don't know if you have to say this, feet squared for each one. Is that okay so far? All right. The pool deck is a stop sign. It looks like it's an octagon. So the area of an octagon, the area of any regular polygon is equal to 1/2 its apothem times the perimeter. Do you remember that formula? So the apothem is this value that goes from the center out to that point, and then we just have to find the perimeter. Now we don't have that, so that's not very helpful, but we can maybe find it. So we're going to start with that, I guess, but you also have to subtract out the area of the pool to get that. So the formula is the area equals the area of the, how do they do it up here? Large octagon, we'll say underscore large octagon minus the area of the pool. So the underscore is like where you're going to want to come back and make that subscript. Okay. And we can do it together if we have time, but we'll make sure we get all the other stuff done. So let's see, how is your format going to work here? Okay, so it does go down to new line. All right. So this is, the area is equal to 1/2 times the apothem times the perimeter minus, I wonder, do you think we can reuse the value from the previous problem, or do you have to rewrite the formula?
Yeah, that's fine.
Okay. So the apothem is 24. Okay, and this is where I don't know how much work you're supposed to do. So in an octagon, we're trying to find this side length. We know that this is 24. Now, because it's an octagon, not a hexagon, you don't get all the nice properties, unfortunately. We need to determine this angle. So So this whole angle you get from the sum formula. So it's the what is it, n minus 2 times 180 divided by n. That gives you the interior angle here. So let's see. So you've got 8 sides. So it's 8 minus 2 times 180 over 8. We'll get that number. That number actually is a nice number. Okay, so it's 135 degrees. So that's the whole angle. So the one that we care about right there is half of it. So it's 67.5 degrees. And we really just want this, base here. So the tangent of 67.5 equals 24 over b. So b equals 24 over the tangent of 67.5. And that gives you like one of these little triangle sections here. So if you double it, 2b, if you double it, you get 48 because you're just doubling the top number over tangent 67.5. And that gives you just one of these. Let me scroll up here a little bit. That gives you one of these 8. So if you multiply that by 8, you get the whole perimeter. So the whole perimeter is 8 times this 48 over tangent 67.5. And that's what I'm not sure of how much of that you have to put in to this, but you know, I don't know. So 8 times 48 divided by tangent 67.5. Minus pi times 18 squared. Okay, so the area is we can get a number for that, I guess. Or we can, I mean, do you know if you have to do it exactly? Like,
I don't.
Okay, so like, I don't know if you have to put this 324 pi in the calculator. So maybe we can do that. So that's 1018 feet squared. Okay, so down here, the apothem 1/2 24 times 8 times 48 over tangent 67.5 minus pi times 18 squared. So we can throw all that into the calculator, I guess. 48 divided by tangent. Okay, so I get 891 feet squared for that. Is that okay? All right, so we're up to patio 1. So patio 1 up here, and maybe if I just I could snip that, but patio 1 is a half circle. Its diameter is 20, so that means that the radius is equal to 10. So the area of a circle is pi times r squared, but since it's a half of that, we just do that. Maybe all these calculations go on the right. Maybe that's what I'm missing here. Okay, so then the area is, maybe that's a little cleaner if we do it that way. The area is 1/2 times 10 times pi times 10 squared. So that's 50 pi. And then we can multiply that out. It's 157 feet squared. Let me know if there's if anything is ever not clear on that.
Okay.
And nice thing is it saves as we go. Okay, so bedroom 1. If you're looking at bedroom 1, it wants master bedroom, but can we do these out of order? Now
Yeah.
let's, okay, well, okay, let's go, I don't know. What a weird house. Okay, master bedroom. The master bedroom is this, is over here on the left, and it's this rectangle subtracting this semicircle. So the formula is the area is equal to the area of the rectangle minus the area of the semicircle, or patio 3. I mean, you could, I don't know how you want to, if we want to say the semicircle is patio 3. So the area is base times height of the rectangle minus semicircle. We just grabbed from 1/2 times pi times r squared. So now we can come over here. We can actually enter the formula. So the base times height is 32 times 26 minus 1/2. And then the radius of patio 3 here, it's just half the diameter. So that's pi times 13 squared. I guess we can get a number now from that. Definitely go back and check these calculations. 566 feet squared. Okay, so the kitchen is a trapezoid. Do we have to say what it is? No, I don't have to say what it is. Okay, so the kitchen is a trapezoid. So the area of a kitchen is 1/2. It's actually the average of the bases. It's base 1 plus base 2, and then when you divide it by 2, that's a half times the height. So the area value is the base 1. It can be either 14 or 24. Doesn't matter. But then you're multiplying it by 18. All right, so that's 342 feet squared for the kitchen. All right, dining room. So the dining room is a hexagon, and the hexagon has a formula like the pool decking formula. The area of a hexagon is 1/2 times the apothem times the perimeter. There's a few other formulas you can use. You can actually just find the area of the 6 triangles and add those together. Meaning like these little triangles in here. But 14 is not the apothem in this case. 14 is the side length of a triangle. It's like, draw it down here. So you have this really nice hexagon, and they're giving you this length here. They're telling you this length is, I already forgot, was it 14? 14. Okay. So a hexagon is actually six equilateral triangles. So this other side is 14. So you could find the formula for it, but you can also just use some 30, 60, 90 stuff. So let me actually make this a little bit bigger just to make that clear. So if you drop down an altitude, and I make this a lot bigger. This is 14, okay? And this angle right here, okay, this is the one where if you do the n minus 2 times 180 divided by n, because n is 6, you end up getting that this whole thing is 120. So this is 60 and this is 30, which means that this is the short side. This is the short leg. And the short leg is always half of the hypotenuse. And then the long leg, which is 7. The long leg is always the short leg times the square root of 3. So the short leg is 7 times the square root of 3. And that's what the apothem is here. The apothem is 7 square root 3. So again, I'm not really sure how much of that you're supposed to show, but we know that the apothem is 7 square root 3. Okay. The perimeter though, like this little piece is 7. And so this little piece over here is 7. So like one side length is 14 and there's 6 of them. So the perimeter is 6 times 14, which is 84. So the perimeter is 84. All right, so I'm just going to multiply those together. 1/2 times 7 times square root 3 times 84. And we get 509 feet squared. Okay, so we'll go back now. We'll look at the office. The office is another trapezoid. That's not very interesting, but that's what it is. It's just like the kitchen. It's another trapezoid. So it's the same formula as up here. You know, let copy and paste be your friend here and just copy stuff like that. So the area is 1/2 times, and then the base one, it could be either 14 or 22. We'll just say 14 plus 22 times 18, and we'll get that number here for you. 1/2 times 14 plus 22 times 18, 324 feet squared. Okay, so we're finally up to patio 1, but I thought we already did patio 1. Oh, you know what? I did patio 3. When I did patio 3, I was really doing patio 1. So good news is we've already done patio 1. So we're just going to copy those down. Oops. Let me see if I can just copy the cells like that. Okay, so now if we go back to patio number 3 up here, the mistake I made is that I didn't put the right number in for the radius. I used 10 because I was looking at the one in the top right. Patio 3 is over here at the master bedroom. Its radius is 13. Well, I guess good. And there's a mistake here. So 1/2 13 squared equals. Maybe we'll just grab the number here. So area equals 1/2 times pi times 13 squared, which is 265. Okay. And then patio number 1 is kind of changed the way we've been doing this. It's 1/2 pi squared, pi times 10 squared, because it's this one top right. The diameter is 20, so the radius is 10, so that's why it's there. Bedroom 1. Method 2. Okay, I'm just looking ahead here. What's going on with part 2?
I think that's just where you put your work.
Oh, we're kind of doing it here though. But okay, I guess some of it's here as well. So I guess let me, because some of it I guess like we could have done already. Like, let me grab a few things here. So like for the pool, like this, I don't know if you want to do it that way, but that's like one of the things you could do. You can always delete that if you don't like it. And then there's more though. There's a little bit more here for that. So it's okay. And then, for example, in patio 3, which I don't know, I guess your instructor doesn't want to work for patio 3, but they do for patio 1. So let me snip some of this in. Is this all you wanted to get to today?
Yeah.
Okay, because I don't know how much more time this will take, or maybe it'll take all the time. Let me get the rest of this. Okay. New snip. Okay. I'm just snipping in some of the work for the I guess this is for the dining room. Losing track of what we're doing. Yeah, for the dining room. Is there a place for work for the dining room? Yeah, there it is. Okay. So pool deck. Oh, pool and pool deck. So both of these in the pool actually go on the pool deck. I'm not sure any work is needed for the pool. It's just a circle. So let's patio number 3. Don't know that anything. Okay, so the master bedroom. Okay, so we do maybe need some work there. Maybe. Do you know if you're supposed to show it for all of them?
Yeah, I think so.
Okay, so like for the pool is just pi r squared. And I mean, I don't know how to say it. It's like that's your work, pi r squared. It's a pool. For patio number 3, it's 1/2 pi r squared. So that's, or maybe you got to say that the radius is 1/2 the diameter. Maybe that's needed. And then the master bedroom, I mean, this is where we're just grabbing some formulas. The master bedroom is the, it's the same, it's like extra stuff here. Okay, so the master bedroom is the area of the rectangle minus the area of the semicircle. Kitchen. Like, to me, we're just copying formulas here. Kitchen is 1/2 base times height. Dining room we got. Office is the same formula. It's 1/2 base 1 place 2. Okay, so patio 1. Patio 1 is like patio number 3 formula. Bedroom 1 is just base times height. I'm really shocked that they're having you do these in here. Now the study and the aquarium we'll have to do a little bit more work on, but in bedroom number 2 is area equals base times height. Patio number 2, area equals base times height again. Family room. So we'll have a little more work for some. Okay, so we're all right. I know we kind of went. I was jumping around a little bit. So we'll go back to bedroom 1. Bedroom 1 has a formula: area equals base times height, and the area is 20 times 22. So the area is 440 feet squared. That's actually quite large for a bedroom. Okay, so now we're going to do the study and the aquarium. Let me do bedroom number 2 because it's just like bedroom 1. That's base times height, and then it's 20 times 20. So that's 400 feet squared. And then patio number 2, it's another rectangle. So it's base times height. And that's 10 times 18. So it's 180 feet squared. Okay. So now let's talk about the study and the aquarium. So we'll grab some. So we have this we have this sector like this, And that's that. So this is the study, and this is the aquarium. Is that okay?
Mhm.
All right. So the angle here, I haven't drawn it real well, but like if you look back at the image, it really looks like it's a 90-degree angle. Although
Mhm.
it doesn't say, and your instructor probably should say. So the area of a sector is the angle at a 360 pi r squared. Okay, but that's the whole thing. That's the whole thing. So, but this is a 90-degree angle. So wait, we can do that. So if the triangle really has a 90-degree angle, let me draw it a little bit better here. This is really a 90-degree angle. How do you find the area of a triangle? Well, you need its base and its height. Well, these radiuses are the same. So let's see if we've got those in the drawing there. I think we do. Yeah, they tell you that this is 20. So the area of the study is just a triangle. It's 1/2 base times height, 1/2 20 times 20. So we'll snip this work in for, and I'm just going to say this, even though it's obvious, I think, but please, rewrite this work before you submit. So the study is just 1/2 base times height. I'll go back and throw that formula in up at the top. So that's 20 times 20. So the area is 200 feet squared. Okay. So now the aquarium, this is where it's a little bit more difficult. The aquarium is the area of the sector minus the area of the study. It's the whole sector slice, which is this formula over here on the right, minus the triangle which we just found. So I'm gonna write it that way. It's the area of the sector minus the area of the study. So that formula is, that's the angle, I'm going to call it x out of 360 times pi times r squared minus 1/2 times base times height, because that's the area of the triangle. Some more numbers in here. So it's 90 out of 360 times pi times 20 squared minus 1/2 times 20 times 20. All right. So maybe so we'll put a little bit more effort into some work down here. Let me just maybe slide a few of these things down. Cut that. So the area of the aquarium equals the area of the sector minus the area of the study, which is angle out of 360 times pi r squared minus 1/2 base times height. It's very repetitive. I mean, it's like we're putting the formulas in two places. I think the instructor had good intentions here, but it seems like you just need to show work and then final answer be a little bit more efficient.
Mhm.
But that's what we got there. So then go back up to the box where we actually have to find that number. This is probably our most complicated one. It's 90 divided by 360 times pi times the radius is 20 squared minus the area of the study. So it's 114 feet squared. It's the rounded answer. Okay. And then family room. So family room is a pentagon, right? Yeah. So the family room, I'll have to show some work for that. We've already done a couple of these. So the area of the family room, you've got a pentagon. Okay, and this time they're giving you this triangle side length of 18. So really we're just going to focus on one triangle. So one triangle here. I'm just going to draw it slightly differently. So they're telling you this is 18. And if you were to use this formula again, n minus 2, oops, 180 over n, where n equals 5, okay? I think you get 108, but let me just check that. So it's 3 times 180 divided by 5. Yep, you get this angle is 108 degrees. So that means that's doubling up here. So this is 64 degrees. So we need two things. We need the height. We need the height here, and actually I'm just going to call this x. Okay, so this one actually has the most work. The sine of 64 degrees is the height opposite over the hypotenuse 18. So the height is 18 sine 64. X, okay, cosine 64 equals x over 18. So x is 18 cosine 64. So this height right here is really the apothem. That's the one you need, because the formula for the area is 1/2 the apothem times the perimeter. This x is only part of this triangle. So 2x is 36 cosine 64. And that's this whole base down here. So the perimeter is 5 times 36 cosine 64. Because it's a pentagon, you've got the five sides all the way around. So that's your work. There's actually quite a bit of work here. So it's 1/2. The apothem is 18 sine 64. Perimeter is 5 times 36 cosine 64. Okay, so let me snip some of this in. I know it's a little discontinuous. I'm also going to send this as a PDF, so you have that as well, if you want to refer back to it. But this is the family room. We'll snip this. All right, and then we'll go back to the formula here, and we'll get that stuff plugged in. So the formula is area equals 1/2 times the apothem times the perimeter, and that's where there's just a lot of stuff going on, because the apothem is 18 times sine 64 times the perimeter, which is 5 times 36. Yeah, 36 cosine 64. And then we'll get a number for that. All of these are formulas you have seen over the year. None of this is new. It probably feels overwhelming because of how many times you have to use different formulas, and you have to really like know what to do to find angles if they're not, or angles and sides that are given. But that, I mean, some of them are just basic formulas you would have known before this class, and some have a little bit more work to it. That looks like it does, and I'm just scanning the document again. Oh, it does say to round all answers to nearest hundredth, which I wish they had said that in the beginning, because it just said to round at the end of the calculation. There it is. Okay. We can redo some of the calculations. We got some time left. What would you like to do?
I don't really know.
Okay. Well, let me just make a few, just remind you, like because these are Google Docs, the instructor can see like that I edited this or that
Mhm.
someone else edited. So I really would recommend you redoing this on your own, typing the formulas in. Do you know how to like convert pi to uh, the math pi symbol?
I think so. I have an extension thing. It's called Math Type.
Yes. Yes. So that would be, I mean, like what we're talking about is like how important is the grade on this? Like, do you need to knock it out of the park, or is it like kind of like good enough? Because really, the only thing you need to do at this point is I would just recheck the calculations and make sure that you get those numbers. And it does say round to the nearest hundredth. So like, for example, like 324 times pi is 0.88, 1017.88.
Mm-hmm.
So you could redo some of those calculations. You could put the 2 as an exponent if you wanted. Google Docs, it's a different key command than in Word. So
Mm-hmm.
I don't really remember what it is offhand, but those means a few little things like that you could do.
Okay.
But other than that, I mean, I think you've got it all here. So it looks like like if it were me, I'd want to get this done now and then not have to worry about it tomorrow morning or tonight. But that's
Mm-hmm.
up to you. It's kind of all here for you. So if there's nothing else, we can stop here.
Yeah. Thank you.
All right. Well, I will send the notes and the screen recording out shortly, but you've got this document. And thanks again for scheduling. See you next time.
Thank you for helping. Bye.
Bye now.